Hi guys, welcome to my YouTube channel Zito. This is Rishu this side. And this is going to be the fourth video in the series of making your own load balancer. And probably this is going to be the last video in the series as well because we will conclude the overall working of load balancer in this video. So a quick recap what we have done until now. So we have understood that how we can run a basic server. Apart from that, we have learned how we can create multiple backend servers. Other than that, we have also learned that how a load balancer can redirect requests to the one backend server. Now, in this video, I'll talk about that how we can use some load balancing algorithm to actually redirect our request to the backend servers. Other than that, in this video, I'll also talk about that how we can check that whether a server has gone down. We will consider like there can be healthy servers or not. So we will consider that too in this video. Now in this video, let's modify our server with some load balancing algorithm that can take care of routing our multiple requests and what happens if when a server goes down. So these two topics are left, which I'll cover in this video. So these two topics are left. So in this video, let's see how we can do that. So let's head to our code editor and start coding. So this was our code from the earlier video where we learned that how we can redirect our request from one load balancer to a single backend server. But as a next step forward, we will learn that how we can actually redirect the request from a single load balancer to multiple backend servers. So for that, let's go ahead and create a list of tuples for our backend server, and let's call it backend server, backend server, and it will contain a list of tuples which will actually contain my list of tuples for backend servers. So let's just copy it, paste it. So we will start at 8081, 8082 and 8083. Now my backend servers are these three ports. So how we will redirect the request from our load balancer? So for that there are different load balancing algorithms. So for the sake of simplicity, I'll just go ahead and use a random server. And for that we can use the library in Python that is random. And we can just go ahead and instead of calling this hard-coded localhost 8081, what we will do is that we can say random.choice, and what we can pass is a list of backend servers. So backend servers. So this will take care of redirecting my request to these backend servers. And for testing it, let's start our port. Let's start our backend servers at these ports and let's see how it works. So I have also shown that how we can start backend server. If you haven't watched that video, please go ahead and see. I've discussed this whole code in details there. So let's start our backend servers. So the backend server is listening to port 8081, 8082 and 8083. And let's create another instance of this terminal. Now we will go ahead and just start this load balancer. So nicely done. Our load balancer is listening to port 9000. Now what we can do is we can go ahead and call localhost 9000. So here, so see, when I'm hitting 9000, it is saying that it has been created from port 8083. Now when I will refresh this, this should ideally take a different host or a different backend server. The request should go and hit a different backend server. So let me pull out the inspect as well so that we can see the whole picture here. So let's go to networks tab and we can refresh it. So see, we have received the response from the backend server 8082. Now when I will refresh again, it's 8081. Now 8082, 8083. So what it does is that my local host is My localhost 9000 is getting the request. Now what it does is it is going to these servers. I mean it is getting randomly chosen, and since my backend servers are running on these ports, my address is getting populated there, and then I am going to hit, and I'm then getting the response from those backend servers. So basically in this place is what different load balancing algorithms are there, that how you are going to choose a server, what is the logic there, and how you are going to distribute your traffic. But for simplicity, I have taken this random dot choice. So so until now, what we can say that our load balancer is successfully redirecting a single request to multiple backend servers. As a next step, now let's see what happens when a server goes down. How does a load balancer takes care of that? So for that reason, I have written this health check function. So what this function does is that it has a list of healthy servers which are healthy, up and responding. So for this healthy servers, let's go ahead and define this healthy server. Right now I'm not putting any server in this list. So this is my healthy server. So this is my healthy server list. Now what you can do is that, now let's go through this code. For a server in backend servers, now this will take a list of backend servers which I have defined here. If you can see the list of backend servers, now it will try to see the response that what it is getting from the servers. Now server 0 will be localhost, now this colon, and then server 1 will be the port at which. Now slash health is basically an inbuilt function which actually goes and checks the health of the servers at those port. Now the port will try to respond with different status codes. Now if the status code is 200, the server, if this response status is 200 and the server is not in healthy servers list, we are going ahead and putting that server in the healthy server list. Else, now if I receive anything except for 200, what I'll do is that if that server is in healthy servers, I'll remove that server because that server is actually giving me errors and not a 200 response. Now, for some reason, if this try block doesn't work, it works like try and catch in Java. The same is here is try and except. Now we will accept that exception as E and we will go ahead and log this. We will say that error during health check for server and we will print the error. Now if that exception occurred and the server is in healthy server, now it is also our duty to remove it from the healthy servers, because what happens is that if a backend server is throwing exception, that is actually not in a healthy state. So this health check function will basically do this task for us. It will go ahead and check whether a server is healthy or not. And for that, we have also used request.get, which is an inbuilt function in this library requests, which we have imported, which will go ahead and see that whether it is healthy or not. Now where to call this health check function? So ideally the health check function should be called when we are starting a load balancer. So before starting a load balancer, we need to call the health check function so that it checks all the available healthy servers and put them into the list. And whenever a server is in unhealthy state, it should push out that server from the healthy servers list. And whenever that server comes again and is able to respond, it should go ahead and put that into the healthy server list. So right now this health check will work. Now what happens if I don't even have a single healthy server? So what we can do is that in the handle client, what we can say is that if we don't have any healthy servers, so if not healthy servers, so maybe I think I have defined something server here, so let's call it servers. So if not healthy servers, so if not healthy servers, what we will do is that we'll call client socket dot send all. This will send a response that we are not having any servers up. So send all function will be called, and we can pass in B that will differentiate the body, and we can say HTTP slash 1.1. This is our protocol. And then what we can say 503. So 503 is the status code when no service is available. And we will say that service is unavailable. Post that, I have also discussed why we put this R, RN and RN in my first video. So you can watch that video for your reference. And we can say that no healthy upstream available. And then we can go ahead and close the connection. So client socket dot. So now let's go ahead and start our load balancer. But in this time, we will not start our backend servers now, because let's see how our load balancer responds when we don't have any healthy upstream, because right now we don't have these backend servers up and running. So it should throw that no service is available. So let's run it. So here we have run the program. Now what you can see is that, see, error during health check for server localhost 8081, because 80, when it tried to check 8081, it didn't receive this request from the health check one, from the health check function. So error during health check for server, and the exception is here, HTTP connection pool. It also didn't get 8082, it also didn't get 8083. So it didn't get any healthy server. So ideally what should happen is that when we will try to do the request, it will go in this one and we don't have any healthy servers. It should say that service unavailable and 503 should be thrown. So let's see when we try to hit this 9000. So it says that no healthy upstream is available, and also the status code is 503, which we tried to send this one. So if you can see here, 503 service is unavailable, and this is the response. The response is no healthy upstream. Now what we can do is that we have tested our load balancer, that in case no healthy upstream is there, my load balancer is working perfectly. It is showing that 503 no healthy upstream is available. Now as a second part, what we will do is that we can go ahead and just start all these backend servers again. So you will see that what happens is that I am going ahead and starting all these servers. So it is listening to port 8081, 8082 and 8083. So now what should have happened is that when this started, now when I'll try to hit my load balancer, now ideally what it, okay, so my servers are up and running, and see, we received a response from 8083. 8081, 8082, 8083. So yeah, it is up and running. Now what we can check is that we will just go ahead and actually shut down one of our servers and see that how it is responding. It shouldn't actually, it should throw exception, it should actually print logs in our terminal, but it should only redirect my request to 8081 and 8082. Okay, for our, okay, so let's see that. So in my backend servers, I'll just go ahead and remove 8083 from here, and we'll just create a new instance for this. Okay, so let it run 8081 and 8082. Now I'll go ahead and create another one for this, and then I'll see we are passing 8083, but 8083 shouldn't be in a healthy state, so it should not redirect any request to 8083, and it should not even return me exception. What it should return me is that it should return me only the responses from 8081 and 8082. So let's run this. Okay, so 8083 got an error, so it is getting printed here. Now my load balancer is listening to put 9000. Now let's see what is happening here in 9000. 8081, 8081, 2, we have got 2, So yeah, that's how our load balancer is redirecting the request. In case my server is going up as well as my server is going down, my load balancer can know how, will know that how things are going and which server is up and which server is not, and can redirect request according to the availability. So yeah, I have shown you that how you can make your own load balancer. And if you like such content, please do give a like to my video and also subscribe to the channel. It motivates me a lot to make such kind of